This is chapter 9.5, which is really section 9.5 in our book, in chapter 9, exercises 13 through 22. And this section of the book has to do with summing sequences to make series. So in exercise 13 through 16, find the sum of the geometric sequence. Well, the formula for a geometric sequence is you start out with an initial value. I'm going to just put the summation notation here, okay? Just kind of this funny backwards looking big E. It's called sigma is equal to, we take our initial value, which is going to be, in this case, 3, a sub 1 over 1 minus r, and r is our common ratio to the power of n, and we divide that by 1 minus our common ratio r. Well, in this case, we need to find a couple things. We need to find what r is, and r, our common ratio, is going to be equal to a sub n over a sub n minus 1. And we can take any term and divide it by its predecessing term, which is going to be, in this case, would be 12 over 6, which is going to be equal to 2. And as far as n, well, that's going to be a little more complicated because we have a sub 1, which is 3. That's going to be pretty easy to find. And let's find out what n is. What we have is 3 times our common ratio 2 to the power of x, we'll say, is equal to 12,288. We could solve this equation by graphing. We could say y equals 3 times 2 to the x minus 12,288. See where this function will touch the x-axis. That will be our value for x. But I'm going to solve this logarithmically. I'm going to put 3 times 2 to the x equals 12,288. Well, we have a unknown in the place of an exponent. Well, what is this exponent? It is the base of 2 to the power of x. I'm going to go ahead and divide by 3 first, just to get 2 to the power of x by itself. So 2 to the power of x equals 12,208 divided by 3. And our base of our exponent is going to be our base of our logarithmic to get this x by itself. So we're going to say log base 2 of 12,288 is equal over 3 is equal to x. So let's go ahead and put that in our calculator. We'll go to log base 2 of 12,288 divided by 3. That should give us our x, which is 12. So equals 12. But n is going to be one more term than that, because with this is our 0 term, and we work that out 12 times 12 more times, our 0 term is going to be, so n is going to be equal to x plus 1, which equals 12, plus 1, which equals 13. So in our formula here, we're going to say a sub 1 is 3. 1 minus r, our common ratio, is 2 to the power of 13. And we divide that by 1 minus our common ratio, 1 minus 2. And to do that, we'll go to our calculator. We go to our first a sub n, that's 3. A sub 1 is 3 times 1 minus 2 to the power of n value, which is 13, and that divided by 1 minus r, which is 1 minus 2, and we get 24,573. We write this down. I hope it's right. 24,573. Now I'm going to try to use our calculator sigma notation to try to do the same thing, and it may be the only time we do this in this video lesson. If we start out with a k value of 0, and we go up how many more times? 12 more times, all the way up to 12, and we take our initial value times our common ratio of 2 to the power of k, we should get the same thing. And let's go ahead and put this in here. We go to our menu. Oops, not our menu. We go to right next to the 9. We have this index here. In our middle row, fourth on the right, we have our sigma index. And we go ahead and put in k equals 0 all the way up to k equals 12. And we have our initial value 3 times our common ratio 2, and to the power of what? To the power of k. And putting that in, we get the same thing, 24,573. And that should give us every confidence that this 24,573 is our correct answer. Let's go on to our next automated problem, which is 15. Same type of thing. We're going to try to find our common ratio r. Our common ratio we get by taking a sub n over a sub n minus 1, any prior term. So we're going to take 7 divided by 42. 7 divided by 42 simplifies to 1/6. So that is going to be our common ratio. Our formula is going to be the same one we've noticed in the past. We have our a sub 1 times quantity 1 minus r to the power of n, and we divide that by the frac 1 minus r. Now in this case, a sub 1 is 42, and we have times quantity 1 minus, we have 1/6. I'm going to put 1/6 in parentheses. So the power of, well, here we have 8. Well, we're going to have to go 9 times, because we're going to have 42 is going to be times 1/6 to the power of 0. And so we're going to make this to the 9th power up here. And put that in parentheses. And then below we have 1 minus 1/6. So let's go to our calculator and put that in. We're going to get control, get a fraction here. We have 42, which is our initial value, times 1 minus, I'm going to put open parentheses, 1/6. And that's going to be to the power of 9 all over 1 minus r, which is 1/6. And we get this fraction. To decimalize the fraction, we press Control, Enter. We get approximately 50.4. So our answer is going to be approximately 50.4. So that's it. We could have used the sigma notation also, like we did in the last one. We want to try that. Yeah, why not? I'm just going to write it out here. I'm going to put a sigma notation here. And we have, in this case, we're going to go from k equals 0 to k equals 8. And we have 42 times 1/6, and we come out here to the power of k. And we get the same thing we got earlier, which is going to be decimalized approximately 50.4. So There we are. Check. Problem number 17. In exercise 17 to 20, to find the sum of the first n terms of the sequence. The sequence is either arithmetic or geometric. So let's go ahead and see if we have a geometric or arithmetic sequence. What do we do to get from 2 to 5? Well, we're going to add 3. What do we do to get from 5 to 8? We add 3. So in this case, we have an arithmetic sequence. And what is our common difference d? Well, that's going to be a sub n minus a sub n minus 1. That's going to be our common difference. So we have 8 minus 5, which equals 3. So our common difference is 3. Our formula is going to be, let me write this right in sigma notation. Our formula is going to be, we have sigma is equal to, we go back to our previous video lesson, we have n, the total number of terms, times a sub 1 plus a sub n, which constitute our first and last terms, and divide that by 2. So the average of the first and last terms times the number n. Well, in this case, n is 10. What do? We have everything we need, except, let's plug in what we have so far. We know n is 10 by definition. We know that a sub 1 is 2. We don't know what a sub n is yet, but we're going to divide by 2. So to find a sub n, we're going to take, n is 10, so we're going to take 2 times our common difference 3 times 9. Why 9? Because n is 10, and so for the first term to be 0 and the last term to be 10, we have to add the, anyway, for n to be 10, it has to be the 9th. So 2 times, actually 2 plus 3 times 9. That's going to be 2 plus 27, which is 29. So 29 is what goes here. So what we have is 10 times 31 over 2. So we can take 10 divided by 2, which is 5, times 31, which equals 155. So that's going to be our sum of this arithmetics that we discovered was arithmetic sequence. Now we go to problems, next on to problem 17, or 19, excuse me. And do we have an arithmetic or geometric sequence? Well, 4 plus what equals negative 2? Well, that's going to be negative 6. And then if we subtract 6 again, we get negative 8. That's not going to work. So what we have is we multiply from one term to get to the next. Well, r is equal to a sub n over a sub n minus 1. In this case, we're going to have, like, say, negative 2 divided by 4. We're going to get negative 1/2. So with that, we should be able to solve this, I hope. We have a sigma. Okay. See if I can make this a little better looking. That's a little better looking. Is equal to, we have our initial value, which is 4. Let me just write out the formula for that. We have a sub 1 times 1 minus r to the power of n over 1 minus r. And so a sub 1 is 4. We have times 1 minus, we have negative 1/2 to the power of 12 divided by 1 minus r, which is 1 minus negative 1/2. Okay, let's put this in our calculator. We have, get this fraction here, we have our initial value 4. times quantity 1 minus, open parentheses, we have negative control 1/2, and that to the power of 12 divided by 1 minus, and we're going to have parentheses, negative, we can put negative 0.5 if we wanted to, 1/2. Okay, everything's in place. We've got our negative there, times that, 1 minus, 1 minus. So we get 1365 over 512, which decimalized equals 2.66602, approximately. So 2.66602. And so this is going to be our answer, which is going to be our sum of these first n terms. Next, let's go on to problem 21. Do we have a arithmetic or geometric sequence here? Well, -1 plus what equals 11? That would be plus 12, right? Well, if we add 12 again, we would get 11 plus 12 is 23, which we don't. So my suspicions are that we are talking about a geometric sequence again. Well, in this case, we have r, common ratio, is going to be equal to a sub n divided by a sub n minus 1. You see how these steps are the same? We're going to take 11, which is our a sub n, divided by -1, so we're going to get -11. So that's going to be r, and now our sigma is going to be equal to our initial value, which is -1, times quantity 1 minus, we have -11 to the power of 9, which is n, divided by 1 minus -11. That's going to end up being 1 plus 11 in the denominator, but that really should be it. Let's go ahead and get to our calculator. We have a fraction. Our initial value is -1 times 1 minus, open parentheses, -11 to the power of, what did we say this was the power of? I think it was to the power of 9, wasn't it? And we divide this by 1 minus, put parentheses, -11, and I think that will do it. And we get negative 196,495,641. So let's go write that down. Equals negative 196 million, excuse me, 495,000, and that's going to be 641. So here we worked out all these odd numbered problems, 13, 15, 17, 19, and 21. I hope this has been helpful to you. Good luck in your exercises, these odd ones and the even number problems you get a chance to work out. Thanks for viewing.